Today we are going to look at the plastics analysis product in SOLIDWORKS. And there's a few main areas that we're going to look at. And we're going to start with just a single part. So we're going to do a fill analysis on that single part. And then we're going to look at a couple of different ways of handling multiple parts. So if we're going to do a family of parts in a single mold, we can do that. And then we're going to end up with a couple of advanced analysis topics that we can do in plastics. And again, since this is a webinar, everybody is permanently muted. So any questions that come up, I'll go ahead and just type them into the question section, and I will either answer them as we go if it's simple and quick, or we will wait until the end and have a question and answer session. So, first thing is, in our plastics, we can do analysis on a single part only. So later when we get into the family multi-part stuff, we'll see it's actually a part in a part or a multi-body part to accomplish that. But we'll get to that in a little bit. So if we want to do a fill analysis on a single part, first thing we're going to look at is plastics uses a tree very similar to SOLIDWORKS, very similar to the other analysis packages like simulation or like flow simulation. And just like many analysis packages, the first thing we have to do is to mesh. And we can either mesh with a solid or we can mesh with shells. We're going to look at meshing with shells. And the first thing it does is it looks through the geometry and determines, what we have as far as different bodies. So that's how it's going to handle the single body or the multi-body that we're going to look at later. We also have the option of, during one of the advanced ones, we're going to look at how we can do insert over molding. So we found our single cavity. We want to look at that. We can set the mesh size, similar to simulation. We can use the slider to set the size that we want, or we can manually type in a number. We can also refine the mesh. So if we have a small feature detail that we want a little bit smaller element, we can either manually select out in the graphics, or we can let it decide for us. So we could do auto. We're just going to do a straight mesh, and we're going to go ahead and get a preview of that. So it meshes nice and quickly because it has analyzed the geometry already. Looks like everything is okay, so we can just go through it. It does a little bit of checking for us, make sure we're watertight, all of that. And then we'll go ahead and OK the mesh. Once we create the mesh, we then get the full analysis setup tree. The main thing we need to look at next is what polymer do we want to actually inject into it? So what is the part going to be made from? If we look in our database, we've got a couple of different ways that we can look at it. We can look at it by family, so ABS, polycarbonate down here if we want to do polycarbonate, or we can look by the company that manufactures the plastic. So whichever way we want to look at it, we're just going to go with generic polycarbonate on this particular analysis. So we'll go into the polycarbonate, and we're just going to pick generic. Now, if the plastic material that we need is not in here, we can, of course, like SOLIDWORKS and like at the other analysis packages, we can create the custom plastic if we want, looking at all the different material properties. We just need to fill that in. We're going to look at what the mold will do for us later in the advanced analysis, so we're going to move past that for now. Next thing we need to do is our fill settings. Two main things that we're setting here are actually three things. One is what's the temperature we want the plastic to be at, what's the temperature that we want the mold to be at, and what pressure our machine is actually capable of. Okay, so the way this works is we don't define a injection pressure. We define a max pressure that our machine can produce, and due to the geometry and the plastic that we've chosen, it will determine whether it can fill or if it will have a short shot. So it's very easy to set up the fill settings. Once we have our material and our fill settings, the only thing left is to select where we want the plastic injected at. And we have the ability to have one or multiple injection locations, whatever we need. So we just go in and we pick somewhere on the geometry. We pick the diameter that we want it injected, and then we go ahead and add that location. Okay. If we wanted to add another one, we just pick another location, add that, and we can go through and add as many as we need. Okay. Once we've got our injection location, we are ready to run our initial flow analysis. Okay. So for that, I'm going to go ahead and jump over to one that's got the results for us. And on this one, I had just a single injection location, not on both sides. So the first thing we really want to know is whether the part is going to fill or not. Okay? So we can look at that. We can animate. And we can actually watch how that plastic is going to be injected in. Okay. So we can see that indeed the part does fill completely. So once we know that, there's still a lot of other things that we want to find out. One is, what is the pressure? Okay, so it takes about 5,400 psi to make this part with that material fill. So we can compare that to what our machine is capable of, whether we've got plenty of extra or not. If the temperature is important, we want to see what the temperature at the end of molding is. Another one that is, what is our built-in shear stress? Okay, so that gives us an idea of where we might have warpage problems once we inject the part. Okay, what we're going to look at a little later in the advanced analysis capabilities is we have some other things that will tell us more information about shrinkage and warpage, but even here in a base analysis, we have some of that built in. Another thing that is very useful is our volumetric shrinkage. Okay, so we can see that anywhere between the yellow and the red, so we're looking at 10 to 14% shrinkage. So that can help us determine the areas in the model that we maybe need to scale up, so that once it shrinks and is ejected, that we have the actual size that we want. Another good piece of information is on our sink marks. Okay, so that's measuring in actual inches how much the geometry in the different areas is sinking. Okay, so we can see, maybe we've got some ribs causing some sink marks and that kind of thing. Kind of show us where we might want to change our geometry or our thickness. Okay. So that's some of the actual result plots. Some other things that are useful are, maybe we want to look at the weld lines. So that's going to show us any place in the model that we have two flow fronts, material flow fronts coming together. Okay, so that can cause anything from just a simple visual defect to an actual strength issue. So that's a good thing to look at. Another thing that we might want to look at is where our air traps might occur. That's where, again, we have some kind of flow fronts coming together, trapping air that can't get out. So every place that we have a purple ball is where an air trap is likely to occur. So that will help us on, looking at our venting to see we can get those out. Another one that, along with the air traps, is looking at the results more in a ISO line form, so we can see where some of these areas where the flow fronts are coming together. So those are some very good visualization tools along with the results. Okay. So that's kind of the basic setup on a single part. Now, if we needed to go into more of a family mold setup, okay, first thing is we'll look over here in SOLIDWORks, and we will see it is a single part with multi-bodies. They happen to all be modeled in as features in this case, but we certainly could do part in a part as well. So either way, so there's a question that just came in. Let's hold off on that until the end. Okay. So either way that we get our multi-body parts created, we can do our analysis on it. Okay. Now, as far as connecting these parts with a runner system, we have two options. One is brand new for 2014, and the other method is always been there. And the options are we can either create sketches, so we can see we've got SOLIDWORKS sketches where we want our runners. Okay. The other option, again, was added in 2014, and that is something called the Runner Wizard. And the Runner Wizard helps us look at some common layouts for runners. Okay, so we can do a edge gate, we can do a submarine gate, banana gate, which that would be for a single part. What we really want is down here on the multiple part layouts. Okay, so for this one, I did a star layout, and I just picked each place on the part that I want it injected into. It created the runner system for me. Okay, all of those can be controlled by diameter and length on both. So the diameter on each end, so you could do tapered runners, tapered gates as it goes into the part. Okay, for this particular one, I just left it at all of the defaults. Okay, so very quickly I did that. Now, if we wanted to use the sketch option instead of the wizard option, we just go into runners, pick a sketch line, and then define the diameters on each end. Okay, so it's very simple to do either way that we want. Okay. As far as our injection location, same idea, only difference is instead of picking the part, because the runners are doing that, we pick the end of the sprue. Okay. And once we get all of that set up, again, same polymer, then it's just running it again. And of course, the first thing we want to know is whether in this case, all 4 parts are going to fill. And then once we find out that they fill, then we want to start to look at how can we balance those runners to get them to fill pretty much at the same time. Okay, so we can adjust diameters individually. We can move around where the gate location is. So there's a lot of different things. We can even run a automatic runner balancing where it will look at it and adjust the diameters of each one to get it to fill evenly. Just the way we set this one up, it fills pretty even as it is. Okay, all the same results are there, even though it's a multiple part. Okay. So that's how we would handle running a family. So taking a look at the question that was typed in a little bit ago, the question is, this will work for any kind of mold. If I wanted to make a mold of a detailed statue, would this do the job? And the answer is yes. The limitation, however, is we only do injection molding of plastic. So we don't do any kind of casting or any other kind of molding, only injection molding. So if that's your manufacturing process, then yes, we can do anything. And the nice thing is we don't have to model the mold. We only model the actual part that we want out of it. Okay? So does that answer that question? Yes. Okay. So let's move on to a couple of the advanced analysis topics. So the first, we're going to continue on with this same part, but now we're going to look at a little bit more of the shrinkage and warpage that might happen. With the advanced capabilities of plastics, there's really two pieces to that. One is an expanded set of results, and the other is we can now actually define a mold material and not just a mold temperature. So there's another question that came up. Again, let's push that one off to the end of the presentation. Okay. So now that we are into the more advanced areas of the plastics package, we're going to look at not just the polymer material, but now we can actually define a material for the mold itself. Okay, so that's going to give us a little bit more accurate heat transfer out of the part into the mold. So it's going to give us a little more accurate temperature distribution, and we're going to get a little bit more in the warpage results. Okay, so we've got a library of different materials that we might want to choose for our actual mold. I just picked just a steel for that. Okay. With this advanced capabilities, we could actually add cooling channels. You know, if we had coolant flowing through our mold to cool it down, we can model those in with sketches and set the diameters and what fluid is flowing through them. So that's another advanced capability we can do. Okay. So once we've defined our mold material, there's really not much else but to run the model. Okay. So looking at the results, we now have 3 different places instead of just the simple flow. So the flow results are all the same. So what we want to look at now is the detailed warpage. Okay, so warp and shrink, same plot for that. You know, on the first part we looked at volumetric shrinkage. Here we are actually looking at a physical measurement of the shrinkage. Okay, so not just a % of the overall size, but physically the red areas are about 30 thousandths. Okay, so a little different view of that. You know, we've got some other things that we want to look at possibly. Okay, so we can look at the shrinkage and the warpage. Okay. That gives us another look at the part. Okay. Again, that accounts for actual mold material here as well. Okay. Now, the last thing we want to look at is we're going to switch over to a different part, and that is an electrical connector that has metal terminals with plastic overmolded. Okay. So again, we are limited to a single part with multi-bodies. So we've modeled in the terminals and the actual plastic connector piece. Okay. When we did our mesh, it recognizes that there are multiple bodies. And we have to make a determination of whether they are going to be a cavity, which is the plastic part, or is it an insert, which means it's going to be either a metal part or another plastic part that's put into the mold and molded around. Okay, so that's where we have cavity versus insert here. Okay, so we picked our one cavity, and then we did our metal inserts. Okay. From there, it meshes just like it did before. Now, when we get into the definition of the material, you can see we've got the polymer like we had, we've got the mold like we had, but now we've got anything that's been called an insert can either be made a polymer insert or a metal insert, and we just pick the material out of the library. Okay. Now, in this case, all 8 of those terminals were the same metal, so we could group them together. Now, we do have the option of each one could have been different, and if that was our scenario, when we do our meshing, we can't just simply make all 8 of those an insert at the same time because they would be the same number. What we would do is pick one of them, make it an insert, and the domain order would be 1 on the first one. Then we'd go to the next one, make it an insert, make sure the domain was set to 2, 3, 4, 5, 6, 7, and 8. And if we had done it that way, here in the insert area, we would have all 8 separate, and we would choose the metal for each one separately. Okay, so that's how we handle insert and overmolding. Okay, when we look at the results, okay, we can see the only thing that is filling with plastic is what we defined as a cavity. Okay, so you can see that the inserts are wireframe, and the plastic flows around them. Okay. Okay. So that is a nice overview of the single part simple baseline analysis to multiple parts to a couple of the advanced capabilities we have. Okay. So let's go ahead and go into some questions, and I'm going to look at the one that's already typed in first, and then as you guys have questions, go ahead and type them in. So the first question is about ribbon of molten plastic that I mold a pattern into it. So that would be similar to a tire rolling through thick mud. So to me, the way that sounds is that's not going to work here because it's not injection molding. So again, that's what we're limited to as far as the actual molding process is mold halves that come together and then injection molded the plastic into it. They separate and we kick the part out. Next question is, would it work on a stack mold? I am not quite sure what you mean by a stack mold on there, so if you could go ahead and type in a little bit more detail, that would be great. The next question is, will this session be available online? And yes, we will put it on our YouTube channel. It might take a couple of days to get it produced and put on there, but yes, this session will be available online. Okay, So were all of these parts designed using SOLIDWORks? This one was not. So you can see it's an imported connector. The copper inserts were. The original part that we started with, yes. So you can see we've got our full feature tree of how it was created. So it's been Well, it looks like we don't have any more questions. If you think of something a little bit later, feel free to email me. My email is cbower@goengineer.com, cbower@goengineer.com. I'd be more than happy to answer any questions you have. Oh, we got one more. Could you import an STL file and design and edit the mold? So we're not really doing anything with the mold itself. So any way that you can get geometry into SOLIDWORks, we can see if it will fill with the pressure and material that you've chosen. Okay, so yes, we could bring in an STL, and yes, we could see if that STL would fill, but we're not really doing anything with the mold. Okay, so another question is show more on the shrink and warp features. Was there something specific there, or the main thing there is the advanced results. So instead of just getting a volume shrink, we get an actual shrinkage in inches. Okay, we can look at due to just the residual stress portion of it, quenching thermal stress. Okay. Okay, so the shrink, warp, and cooling are all kind of grouped together in the advanced stuff. So adding the coolant lines, being able to define a mold material, and then the advanced warp results. That's what goes along with those. Okay. Well, thanks everybody for coming to the webinar. And again, if you think of other things, go ahead and send me an email, and I will be more than happy to answer.